So looking at engineering majors, a little bit about the differences between what they do, kind of the fields that they work in, and more information about kind of what to expect in different majors. So there's lots of different areas of engineering you can get into at Penn State, and we have some listed here. Some of the larger specialties, maybe aerospace, chemical, civil engineering, those you can take at University Park. Computer, electrical, industrial, mechanical engineering, we also have here at Behrend. And some other specialties that you could go into, architectural engineering, biomedical engineering, environmental and energy engineering, materials, manufacturing, nuclear and petroleum and mining, and software. So these are all areas that you can move into. You've heard these terms before. I wanted to talk about a few of them a little bit, focus on some of the larger ones, and kind of let you know what we have to offer. So when we're looking at majors, there's always some overlap between the majors, and you need some information from outside the engineering fields, but there's usually lots of different crossover. Some of the engineering majors are very closely related to each other, so we kind of consider it to be interdisciplinary in the sense that there's a lot of crossover between the different majors and between some other skills that you might find outside of engineering. So let's talk about computer engineering. So this is looking at the computer hardware, the system that goes into a computer, the networking that occurs. So you can be working in, how do computers communicate with each other over the internet, communicate between the different components within the computer. So there's different networks, different ways such as Wi-Fi or Bluetooth in order to communicate. You can be working in maybe into the hardware design. What are the individual components that go into the computer? What is that? How do you make that hardware? How do you make it better and smaller and faster? You can be working on the programming end of it. How does the operating system work? How do you make that more efficient without getting too large? How does it control everything? You could be even looking into other areas of engineering, such as biomedical engineering, and looking at how do you make the software and the hardware in order to run components that are keeping people alive or helping people in a hospital, in order to take measurements, and such as MRIs and ultrasound imaging. All the technology needs computers behind it. You can also be looking at maybe just an intelligence of a machine and trying to improve what they can do without human interaction. So there's lots of different areas in computer engineering. Computer engineering is a little bit related to electrical engineering. It's kind of an offshoot of that. But in electrical, you're not talking quite as focused into the computer itself, so it goes broader beyond just a computer. So you could be looking at electromagnetics, so what is in the communications besides computers, or including computers, but how do you set up networks and in order to communicate over long distances, such as cell phones and satellites and radio and those types of things, television. What are the electronics that goes into not just computers but into other components? Any little handheld device that you might find has electronics in it that you need to have designed. There could be signals coming in and out that you need to read and be able to analyze. There could be analog signals or digital signals, and how do you make those two work together? How do you convert between them? So like with MP3 players and things like that, how do you send that information out, and how do you receive that information? How do you analyze that information? You'll be working the power systems, trying to make things more efficient, trying to use the power, make the power better in order to provide the power without much waste. There's also different actuators and sensors you can be working in. How do you make things move? How do you interact with the world? How do you sense information in? How do you make components that use all that information and make them work well? How do you control things? How do you set up a control system so that when you want something to operate, you have knobs and buttons that you're pressing? How does that make something work? There's a whole control system there in order that things are working properly, and that when you're turning some knob, you want something to move, it happens at the right speed, it happens that it doesn't go too far, it knows when to stop. So that gets into a little bit in robotics, but there's other areas too that relates to, just with small components that you might have to adjust. And maybe optics even. There's a lot of communication that happens optically, and lasers and fiber optics, so there's lots of areas where you can get into electrical engineering and communication. Industrial engineering is a little different. They don't usually make components. They're not usually involved in making something. It's usually looking at the processes. So you could be looking at manufacturing processes in order to make them more efficient, make them better, save money for the company in the end in order to set up their assembly line or set up their manufacturing line in an efficient manner so that product is moving through faster. Maybe working with quality control to make sure things are being made better. You could be looking at in management and providing the supply chain and logistics. So you're getting supplies, you're kind of making sure that you're getting your product supplies in so that you're using them as fast as they're coming in so you don't have an overstock of supply, that you're sending out your product when it needs, making sure that that whole chain is happening efficiently. You could be working in human factors. That's another area where industrial engineers work in. So it started off with maybe assembly line processes and trying to make sure that people are putting things together properly and more efficiently and faster, and making sure that things are aligned well so that people can put them together faster. But it can go into other areas too, just with ergonomics and using components and trying to set up a system so that it's easy to use by the end customer. You'll be looking at operations and how does a system work that is outside of manufacturing system, so like a healthcare or banking or a retail store. As people come in and they walk into the facility, where do they go, where do they see, how do they move through the facility, like a store or a bank or a hospital, in order to achieve their function and being there efficiently and getting out the door efficiently and fast. So Disney uses places, people like that to set up their systems. Banks and hospitals use them to set up their systems in order to make sure people are going through the process well. We can also do like economic analysis, trying to determine, if I'm going to buy some piece of equipment, how long is it going to take me to pay that off in the profit that I make from that equipment? Maybe what's the depreciation of that? How do I keep track of that money? Industrial engineers will help keep track of that. In mechanical engineering, you're looking at the design and analysis of mechanical systems. So any types of machines, anything with moving parts, cars to planes, to wind turbines in the picture there. You're looking at maybe how do you control the vibrations inside, how do you analyze the motion or to make sure things are not going to fail, how do you make sure things are strong enough. Maybe with energy systems, you're looking at putting up a power plant and you're trying to make sure that you're heating up the gas or the liquid fast enough and extracting all the energy out of it that you can. You can set up manufacturing processes in order to process materials, in order to make products out of materials. So understanding the material and how it reacts is helpful in setting up an efficient manufacturing process. You can be looking at biomedical applications where you're trying to build structures that, such as artificial limbs and artificial organs and things like that, that you have to use the mechanical properties that you need to know about in order to design those well so that they're going to last. So you can get a lot of different areas into mechanical engineering. It's pretty broad. And there's other fields of engineering that are related. We have an interdisciplinary business with engineering program at Behrend, where it's a business degree, but you're taking a lot of engineering courses. We also have engineering technology programs, which are a little more hands-on, less on the theory, but you're more in getting something made and how are you going to make that happen. We also have a number of minors and certificates that are provided for that engineers could take easily, such as the supply chain management, technical sales, physics and math minors are easy to get because you take so many of those classes. So just talking about focusing on the interdisciplinary business and engineering major, it's kind of broken down into a business core where you're taking a lot of real basic business classes and getting a good understanding of how that works. You're taking some engineering core classes so you have an understanding of how the engineering works. There's your general education classes that you need, and then in the end you have a focused module that you take which focuses in one of those areas. You can go into like a finance area or you can go into manufacturing area depending on what you're interested in. But it's a way that you can get some of the business background, some of the engineering background in order to be a go-between between the business office and the engineering office. You're the person that could communicate well, that understands the needs of the engineer, understands the needs of the accountant or the marketing person in order to try to make a product go to market sooner by being that go-between. And it's helpful to have internships, any opportunities you have to do some work as an engineer is helpful to kind of get you an understanding of what do these engineers do. You're around other engineers to see what they do, and you're getting a little taste into what they do. You can look at maybe some full-time work over the summer. That's a pretty common thing that happens with a lot of students. You get paid for that. It's good on your resume. It's a good, valuable experience, helps you with your classes too, to understand why you're taking those classes. A lot of students may choose also to work part-time during the school year. It gets into, balancing your schoolwork and your job a little bit. That can affect your grades some, but if you can manage some time during the school year, you can get some. There's opportunities to work as an internship there also. A co-op is a more formal program where you might take a summer and a semester, so like a spring, summer, or a summer, fall, and you take that semester off and you're focusing on work and you're getting a more valuable, a longer experience where you can get more into it. It will delay your graduation a little bit because you have to take that semester off. A lot of students will find that it's a valuable experience. A lot of times they'll get hired by the company that was doing the co-op with them. You can maybe get credit for that depending on the major you're in. You can look into that, but that's a possibility also. So that's a little bit about some background in engineering and the different majors and the opportunities that you have available.